Can you see my screen?
Yes, sir.
Okay. Today we are going to start with the basics of structural engineering. Basics of structural engineering. Okay. So can anybody tell me what do I understand by structural engineering actually? What is structural engineering? Hello. What do I understand by this subject? Or you can say what is done in the structural engineering?
We design an analysis of structures, different structures.
Yes, we are designing and we are doing the analysis. Okay. So structural engineering means we can say any structure uh, which is on the earth, especially I'm talking on that. Definitely it has loads, dead loads and other loads, and whatever loads are coming on the structure, it should withstand the loads safely. For example, if there is a, let's say, a room, and if we are putting load on the room, we are not putting, see, many times dead load is there, self weight due to the gravity, and due to that, whatever this arrangement you are preparing, this arrangement is called as a form or shape. So you are creating a shape, then you are suggesting some materials for that. So there is a material such that whatever loads are coming on this, they are safely carried by the material which is proposed, and this load will go directly in the foundation. So generally this is a, the, we can say, a structural engineering philosophy. So we are taking care of the loads and their effects, and ultimately what is the shape or form of that structure is, it should remain same or it should remain intact, then and then it will be safe, remain intact, or the form and shape should not change. So it should not change, right? Then and then whatever shape is there, if it is there, then it satisfies its requirement. So if you are considering this as a frame or building, then it, the shape what is proposed here in the drawing, it should remain same after the load is there. So how, otherwise what will happen, it will deform or it will collapse, and it should not collapse. And uh, you should do such a arrangement, and we can say proposing the material and this such that the loads will be carried by this structure safely without any deformations or deflections, too much deflections, we can say. Okay, so this is in general structural engineering, and in structural engineering we have a lot of projects. Either it may be bridges, types of structures, we can say, we have already seen that structures. It can be retaining walls, it can be buildings, it can be water tanks, it can be industrial sheds, right? And there may be, say, dams also, dams, chimneys, poles. So actually even our body is a kind of structure also. So everything which is on the earth is a structure, we can say, in general, uh, in the object form. There may be, say, our human body is also a structure. Then trees, whatever trees are there, they are also a structure. Okay, so in totality, there are a lot of structural types in general from micro to macro level. Micro to macro. Macro means bigger structures. See, Earth is also kind of structure, we can say, bigger size of structure, we can say. Micro means there may be thin, small structure also, or very small structures which are microscopic, or we can say atomic structure. So there is atomics and electrons. It is a kind of structure also. So there may be smaller structures or big size structures. That means micro or macro. And within that also there are a lot of structures available. Now we are dealing with the mostly in structural engineering, as far as civil engineering is concerned, we are dealing with the static structures. Static means, what is meant by static? What is meant by static?
Stationary.
Yeah, it is stationary or which doesn't move. So we are mostly dealing with this. So there are dynamic structures also, dynamic or moving structures. Can you give me example of dynamic structure? Dynamic structures which generally moving objects, you can say, or structures. Any example of dynamic structures? Yes.
Floating bridge.
Hmm? What?
Floating bridge.
Floating
Floating.
bridge. Okay, floating, but okay, you can say better way. We can say ship. Ship is a moving object or moving structure. It can be ship. It can be car. It can be rockets. Okay, so these are the moving objects or moving structures, right? And what are the stationary or static structures? These are the structures which we discussed. They are stationary and static. They don't change their position throughout the life of the structure. Okay. So they are always stationary throughout the life. And these moving objects or dynamic structures are, they move with respect to the location or space, we can say. In space, they change their position. But these static structures, they don't change their positions. Okay, so these are the, and we are mainly in our part in civil engineering, structural engineering part, we are dealing with these static structures. So actually, we can say the complexity is very much reduced in our profession, we can say. See, these dynamic structures generally they are designed by the mechanical engineers, aerospace engineers, and so on. So there are other engineers who are dealing with this, but we are mostly dealing with the static part. And static part is very easy to understand and even do the analysis design like that. So we can say our structural engineering is very easy. Now, as I told you, when there is a structure, say I generally take example of frame only. You might have seen these kind of frames. Entrance gate is there like this. You might have seen. Do you know this entrance gate frames in societies or wherever you might have seen in temples? There is an entry from this portion, and the column is there. Then horizontal beam is there. So this is a kind of structure we can say. And so due to its we can say self weight, there will be load, and the load is in the gravity direction. And what will happen due to the loads to this structure? It will deflect or deform, we can say. Okay. So that means this load and this is a deformation or deflection. So in general, in any structures, there is a cause. So they follow the cause and effect rule or principle. Cause effect. Okay. So in structure, what is the cause in general?
Loads.
Yeah. So loads, or you can use word force. Loads or force is a cause. And what are the effects in general?
Deflection.
Yes, deflections or we can use word deformations, or so deflection may be vertical or vertical deflection, straight deflection we can say in columns as we see, or it may be bending like this, and this column also will try to settle down vertically, right, due to this load. So there will be this delta vertical, so this column will try to reduce its length. So this is, we can say, translation or vertical deflections, and this curvature deflection we call it as a bending deflection. Okay, so these kind of effects are there in general in the structures, and due to the deflection what happens, so there is a load, there is a deformation. So what happens due to this, what happens in the material that you are,
Stresses are developed.
yes, traces are developed, right? So in the material there will be stresses. In the material, stresses will develop. And to calculate the stresses is nothing but what? What is stress? Force upon
Yeah.
sectional property, area or whatever it may be. Section property, cross section property we can say. So either if it is column case we can say, and the load is axial load P, then area will be the stress, axial stress. If it is a, let's say, beam, in beam what is there? There is a bending moment. And what is the sectional property for that? Let's say sigma B is the bending stress. So what is the sectional property?
Z.
Z, right? So yes, so due to the loads, deformation is happening, and due to the deformations there are stresses, internal stresses. So the stresses are generally internal, we call it as. So there is something internal and something external. So the loads are external, okay, and the stresses are internal, within the material, internal within material. And definitely in structural engineering what we are taking care that whatever stresses are coming, that means this material should not crush or the material should not crack. So we make sure that the stresses which are coming here, they are less than permissible limits. Okay, so they should not exceed these limits, because every material has a capacity. So permissible capacity or stresses we can say. So every material has a permissible capacity. It has a capacity. So you should not increase the load more than its capacity. And if the load is more, then you can increase the size of the section. Okay. So this is in general the philosophy of structural engineering, and it follows the cause and effect. So we should learn the causes first in basics, and then we will learn the effects also. So in any structure. So let's go in detail regarding the causes, and the main cause is load, we can say, load or force. Okay. So what kind of forces are there actually, or loads are there in structures? What is the fundamental basic load which is there in the structure?
Gravity loads,
Live load,
lateral loads.
dead load.
Yes. So gravity load, or we can say
Dead load or live load.
dead load. Yes. Or we can say dead load or live load. So these are a fundamental, we can say,
Basic.
loads. Now, for example, we can, let's say, if we have a structure like this, let's say we can take an example of building here, in which okay, and let's say So there is a brick wall, let's say. So this is a room. Okay, I'm just checking. There is a footing also, let's say. So this is a slab, this is a beam, then there is a parapet wall. Okay, and let's say if we have something here in between, we have a floor. Okay, there are two slabs, let's say. So generally, if you consider this as a concrete material, this is a brick. And let's say there are humans which are using these rooms, then there may be furniture here, right? There is a furniture. There may be maybe fans like this. So these walls, so as this is a brick, what do you understand by the dead load? Tell me, what do you mean by dead load?
Self weight of the material.
So yes, so dead load is nothing but self weight of the material, self weight. And why there is a weight to the material? Why weight is there to any material?
Mass of the material.
Yeah, so because every material has a mass, and all of you know that there is an acceleration due to gravity. Acceleration due to gravity. And due to this acceleration and mass, all of you know that force is nothing but mass into acceleration. So in our case, this force is nothing but m into g, gravitational acceleration. Okay. So this force is nothing but a dead load, we can say, right? This force is nothing but dead load. Let's say we have one object like this, which is resting on the ground, and the object is having mass m. So the weight of this object will be W will be m into g. Okay, mass into acceleration. So every material has a weight due to acceleration and the mass. So either it may be brick wall, or it may be concrete material, or see, there are two materials here. And there is a weight to the human also. All of you know that human is also having mass, and it will also have a weight. So this furniture will also have a weight. Even though it is a timber, it will have a weight. This chair will have a weight. This fan will have a weight. So every object is having a dead weight or self weight, we can say. Okay. And if you want to calculate the dead load or the self weight, how can you calculate the self weight of any object?
Considering density of the
Yeah,
material.
so see, every material is having a density to that. Okay, and if you know the density of the material, then you can calculate the weight of that material, right? So let me tell me for first thing, this force or weight is equal to mg, or force is equal to mg, whatever words you use. Weight is also force, we can say, which is a weight is generally, we can say, gravitational force. So force is also mg. So what is the weight unit of the weight or unit of force? Units.
kg
Uh,
Newton or kg.
generally, see, we can say Newton, or you can say kilonewton, whatever means, depends on the weight of the mass is in kg actually. Okay, and this, what is the unit of this gravitational acceleration?
10 meter per second square.
Meter per second.
Yeah, so unit is meter per second square, right? So you should know these units. So please, in structural engineering, keep in mind you should know the units of each term, whatever we are using in, and please don't forget to write the units. See, there are many times students, candidates, they make mistakes if they miss the unit part of the any calculation. So don't miss that. You should know each and every unit of the term which you are using in the equation or in the mathematics. Okay, so if you want to calculate the weight of any object, You want density. So what is density actually?
Mass upon volume.
Yeah, so generally density is nothing but mass upon volume. So there is, we can say there are two types of density. One is the mass density, which is nothing but mass upon volume. And there is second density, which can be used to calculate the weight. There is weight density. Okay. What is weight density?
Weight upon volume.
Weight upon volume, right? And you know that weight is nothing but this mass into acceleration, right? Now, mass, what is the unit of mass? Mass of any object, kg. And what is the unit of volume? What is volume?
Meter cube.
Yeah, if you are using unit as a meter, it is meter cube. And what is volume?
Cubic meter.
If it is a rectangle or cubical shape,
Area in L into B into H.
H.
L into B into H, or we can say area into height. You can use any term. So volume is so why it is meter cube? Because length is in meter, then width is also in meter, and height is in also meter. So it will be meter cube, right? So see, it may be meter, it may be centimeter cube, it may be cube, it may be say these are the major three units. Okay, so mass density is kg upon meter cube. So kg per meter cube. And what is weight density?
Ton per
Newton
meter.
per.
Yeah, so this m into m, see, weight is equal to what we said, mg. So where this m is in kg and gravity is acceleration is meter per second square. So kg meter per second square, we generally call it as a Newton. Okay, n Newton, right? So this will be in Newton upon meter cube. So this is the weight density. Now tell me, I'm just asking you one question that let's say we have, so for example, that means if you want to calculate the weight of any object, what you want? Weight density of that material, right? So every material has a different weight density. So there is one more word which is used, which is we can call it as a unit weight. Okay, unit weight of that material. This word is also mostly used, unit weight. So for different materials, we have different unit weights or weight density. So if the material is having more unit weight, so its weight will be more or less? More unit weight.
More.
Weight will be more.
Weight will be more, right? And if it is less, it will be less, right? So for example, can you give me example that this weight of this is less and this is more for the same volume? For that, you should know some materials actually. So we can take example of brick material. We can take an example of concrete. Let's take an example of steel. There is also one material which is water. Let's say I'm taking simple materials which are generally used in structural engineering. There may be some other material also, like soil or something. Okay, so these are the materials which we use in construction. What is the general unit weight of this brick?
20 kilonewton.
Okay, 18 to 20 it is there. Let's take 10. So what is the unit weight? What is the unit of it?
Newton per meter cube.
Kilonewton per meter cube. What is the unit weight of concrete?
25.
24.
Yeah, 24 to 25. Let's take for
25.
simplicity meter cube. What is steel?
750.
Yeah. 78.5.
kg.
Newton per meter.
Okay, and then the water.
10. 10.
10 kilonewton per meter cube.
So this whatever these simple materials are there, you should remember or you should know this unit weights. And soil it is generally
18.
16 to 18 kilonewton per meter cube. Okay. Now, what do you understand by this term actually? Let's say take an example of concrete. What do you understand? 25 kilonewton per meter cube means what? "25 kilonewton per meter cube." What comes in your mind whenever you see this term? You see the number, you see the units, and what you understand by this?
Weight of 1 meter cubic of concrete is 25 kilonewton.
Yes, yes. So let's say if you cast a concrete, a block, solid block like this, whose dimensions are this is 1 meter, this is 1 meter, and height is also 1 meter, and this is a concrete. So if you measure this block weight on some weighing machine, then how much will be the weight of this block?
25 kilonewton.
So it will be 25 kilonewton. Will be the weight of this block. Weight I am talking. That means for any 1 meter cube of the block, the weight is 25 kilonewton. So if I ask you, what will be the weight of concrete whose dimensions are let's say this is your 0.1 meter this height, and let's say this is 1 meter, or let's say 2 meters, and this is 1 meter. Okay, so what will be the weight of this concrete plate? So what is the
25 into size of block.
so yeah, so we have seen that weight is nothing but dead weight, we can say. Dead weight is nothing but, or let's say go again back. You know that your unit weight is nothing but weight upon volume. Yes. Now, if you know the unit weight, you can calculate the weight of any object. So weight will be what? Unit weight into volume. See, I'm taking so much simple things. I know that, but the reason is many times we have seen the candidates don't know this also. I don't know why, but it's the case. So weight means you need to multiply the unit weight of that material into volume of that object. So weight is
Okay.
how much unit weight into
2 into 1 into
volume.
1.
So how much is the unit weight of concrete? Sorry.
25 into 2 into 1 into 1.
So write down the unit weights. 25 kilonewton per meter cube into what is the volume?
2 into 1 into 1.
So 2 meter into 1 meter. See, I'm deliberately writing the units also because see, many times we may miss the important part. So 25 into this 2 into 1.2. Okay.
50 kilo.
And this kilonewton upon meter cube, and into meter into meter into meter means meter cube. So this grows. So how much this?
5.
5 kilonewton. Okay. So this way we can calculate the weight of any object. Only you need to multiply with the unit weight of that material. And that means what you should know? You should know the unit weight of different materials is the first case. If you want to calculate the dead weight or self weight of any object, first of all, you should know the unit weight of that material. And second thing, you should know how to calculate the volume of that object. It depends on the shape. All of you know this. So how the volume is calculated. So unit weight we have seen. These are the unit weights of different materials. And how to calculate the volume. So if it is a rectangular or cubical shape like this, This volume is nothing but L into B into H, right? Simple for rectangular cube. If it is a, let's say, cylindrical shape, how to calculate the volume? This area
Pi.
into this height. Yes.
Pi
So
by 4
area,
d square into h.
yeah, so this area, hatch area means circular area, pi by 4 d square. D is what? Diameter of this circle. This will be the area into height. So in the
Yes, sir.
similar fashion, there may be different shapes of which you should know. So you will get this in ready reckoners, either on Google or in books. But at least basic shapes you should know. If it is a, let's say, triangle, okay, let's say this is your triangular shape, and then this is your, let's say, so this area is of the full part. Don't forget, this is a solid. We are filling the material within this shape. Total filling, complete. What will be the area? The area of this triangle. Volume will be the area of triangle. So if it is, let's say, base and this is height, then it will be,
Yeah.
this will be h. So half base into height into
Right.
this length. Let's say this is your length of this object. Okay, so this is also one of the way. Now this is solid. We are filling the material full within this shape. Don't forget. See, many times people even do the mistakes. Now I ask you, what is the weight of? Now you, once you know the volume, what will you do to calculate the weight? Tell me, if this is a steel material filled in this object, what will be the weight of this object?
78.50.
So unit weight of steel into volume. And what is the unit weight?
78.50.
78.5 unit is kilonewton per meter cube, and volume will be whatever this. Now please keep in mind, whatever units you are using, they should be consistent unit. Consistency means if you are using the unit weight in meter cube, then your volume should be also in meter cube. Don't write in centimeter cube or mm cube, right? It will give wrong answers. If you are using meter cube here, then use meter cube in volume also. So many times we get the dimensions in mm. Let's say this L is nothing, 4000 mm. This base is, let's say, 300 mm. And this height is, let's say, 200 mm. Okay. So if it is the case, how will you calculate the volume? Half base. How much base you will take here in this equation?
0.3.
0.3.
0.3 into height is 0.2
0.2.
and into L is
0.4.
4 meters. 4 meters, 4000
Okay.
mm.
Okay, sir.
Okay. So you are taking all the units in that because you know the unit weight in these units. So your volume should be consistent with this unit weight. Okay. So this is general way. And now I will ask you one more question, that if you want to calculate the weight of, let's say there is a rectangular tube. So I have one rectangular tube. All of you know, do you know this? There are rectangular tubes available in steel. You might have seen
Yes, sir.
rectangular, square, or let's say take a rectangular example. And let's say I have a thickness of this object, tube, say 10 mm. 10 mm. Then this width is, let's say, 100 mm. And depth of this tube is, say, 500 mm. Now, if I ask you to calculate the weight of this tube, so our aim is calculate the weight, self weight of the tube. Let's say self weight of the tube. How to calculate? This, let's say, material is steel material. How to calculate?
Unit weight.
First, we will find volume.
Yeah, so see, steel unit weight, you know, volume, let's say, how to calculate the volume?
Total area minus the area of the inner rectangle into
Yes.
thickness.
So external area minus internal area, right? Because I want this green area only, because this is the only material available. This is a hollow portion. Don't forget this. See, many times people do that. They multiply this 100 into 500 into 10, and I don't know why they do like that. So you need to subtract the outer area from outer area, the internal area, so that you get the hatch green color area, right? So internal area. That means you should know this dimension also, which will be something 180, isn't it? And this height will be internal 500 minus 20, 480, right? So external area will be 100. So as we have discussed that its unit weight is 78.5 kilonewton per meter cube. That means I should write the volume in meter unit. So it will be external is 0.1, 100 mm means 0.1 into 0.5 will be the external area minus 0.08 into 0.48, right?
Yes, sir.
And once you get the volume in meter cube, multiply that volume by the unit weight. That's it. You get the self weight of the object. So I would say in calculation of the weight, self weight, the volume is the crucial thing. So you should know each and every volume and volume of the material available. Okay, don't forget this. See, don't use only equation that LBH. So multiplying 100 by 500 by say 10. Don't do it that way, right? Now there is one more term. So this area, actually we are calculating this area, but how to calculate the volume? So this will be in meter square actually, isn't it? So as it is area, so it will be meter square. So you want the length also, isn't it? Don't forget that your requirement is of the length also. Volume is area into length. So this L, let's say this L is nothing but 4 meters, 4000 mm. Then you can multiply this with the length, which is 4 meters. So you'll calculate the area here, area into the length, you'll get the volume in meter cube, right? So this is the basic part of calculation of the weight. Please remember the material unit weights. Now there is one more thing. Whatever you do in structural engineering, whenever you are doing any projects, you should get a feel of what you're doing. Get a feel. Either you are doing the mathematical calculations or whatever, you should feel that. So feel is really, we can say, subjective term, but it is really required. Because whenever we take any decision on any projects, so our understanding is very much important. And for this understanding, we want definitely logic and maths. Logic and maths is definitely required. And apart from that, you should have a feeling also. Don't forget this. So whatever you are doing, there should be feeling, and mostly the feeling means, we can say, there is a common sense. So this is related with the common sense, we can say, feeling. Now, see, what do I mean by this? The way we have seen, what do you mean by this 25 kilonewton per meter cube? When I asked you, then you said that, yes, if you consider a block of 1 meter by 1 meter by 1 meter, if you fill this with the concrete and if you weigh this on the weigh machine, you will get this weight. That is the meaning. So for every 1 meter cube of the material, the weight of that material will be 25 kilonewton. So you are feeling now this. Now there is one more thing regarding the feeling. Many times we don't understand the unit Newton or kilonewton. From our childhood, we are more comfortable With which unit of the weight?
Kilo.
This we have learned in the college.
kg.
Kg. So kg is a really good unit. Why I'm saying good? Because I can feel it. All of you know that. What is the weight of say human or a person, we can say? General weights.
50 to 60.
So it may be 50 kg, it may be 70 kg, like that, right? There may be people of 100 kgs also. So once you see this 50 kg or 70 kg, you can feel these numbers. You get a sense of that weight, real weight. I know that feeling and sense is a subjective term, but still you get a feel of that by relate. So you can learn through relativity. Through relativity, through comparison, you can learn. So in structural engineering, I would suggest all of you, please create this parameter, or I would say you create your calibration. So if you take an example of person having weight of 70 kg or 100 kg, then you can really relate that. So that person is, and there may be some different materials. Let's say there is a tank. Generally, we don't get the feeling in kilonewton or newton. Huh? So what will be the 70 kg means how much newtons? So mass 70 kg means how much
700 meter.
into,
700.
if I want to put this in weight format, so I need to multiply this by how much?
10.
Yeah, generally 10. It is 9.81, but for a simplicity, multiply this by 10. So how much will be the weight here in this case? 700 Newton, right?
Newton.
See, generally we cannot feel this number. If I tell you that my weight is 700 Newton, will you really get a feel of that number? Isn't it? So many times, whatever may be the unit you are comfortable with, which you can feel, you can use those units for your understanding. That is the meaning. I know that for calculations in our structural engineering, we are going to use these units for the forces and weights, Newton and kilonewton mostly. But generally we get feel with this kind of unit. So it doesn't matter, you need to understand whatever maybe the unit you take. But generally, see, I am not really comfortable with this unit as far as understanding is concerned. 700, my weight is 700 Newton is really not, I don't really feel that. So this way, I want to ask you one question. Let's say there is a water tank. There is a tank which is filled with the water. So there is a water inside the tank, and the dimension of this tank is 2 meter by 1 meter by 4 meters. Tell me, what will be the weight of water inside the tank? You can use your units. Huh? Volume 2 into 1 into 4.
8 meter cube.
And what is the unit weight of this
10.
water? 10 unit.
Kilonewton per meter cube.
So it will be 80 kilonewton per meter cube. So not per meter cube, because it is only kilonewton, right? So it will be 80 kilonewton of weight for this. So if you consider in kg, how much will be this? So Newton में कितना रहेगा? 80 into
1000, 80 into 1000.
1000. Yes. So whenever we convert in newtons, it will be 1000 into 1000. So how much is this? 80,000 Newton. If I ask you what is the weight in kg?
80 into 100.
8,000.
So divide by 10, because we know
8000.
that if you want to convert the weight in Newton, you need to multiply by 10, and if you want to convert that weight from Newton to kg, divide by 10. So it will be 8000 kg, means how much? 8 metric tons. So generally we are comfortable with this unit, either kg or tons. So you have seen these weights many times. What in practical, we generally use this weight, kg and metric tons. Okay, so generally before our education, the units used in the even IS code where kg stresses were in kg per cm square, weight was in kg and metric tons, right? But nowadays we are using SI units, which is having Newton and kilonewton in that. All right. So this is the in general regarding the weight and the meaning of it. So if you use this, can you calculate the weight of any object, right? And this weight is, as we are calculating the weight is generally in which direction? Downward. So weight of any object is always in downward. So this weight will also be downward. This will be also downward, right? Towards the earth. I hope you got this. Now we have seen that. So here this person, this furniture is having also a self weight. Then why we are saying them as a lie load? Why it is lie load? Why not dead load? Even though they are having dead load.
They can be moved anywhere in the room.
Yeah, they can be moved anywhere in the room. So they are not permanent throughout the life. They can change. This furniture can move. The person can move. So that's why we call these weights as a live loads. Fundamentally, they are dead loads, we can say. But as they tend to move, we can say it is a live load. Okay. Now let's go to the second concept. I think for calculation of dead load, you understood what is required. Now let's see the second term. So dead load. Load is, we can say load is nothing but load, or we can call it as a force. Okay. So what do you understand by force? So force is a cause, we have already discussed. Force is nothing but a cause. So what happens due to the force? So if there is a one block, we can say, and let's say this block is having a self weight. We can say self weight as a P. So what will happen due to this? What will be the effect on this due to this weight? क्या होगा?
There will be reaction.
No. I'm just asking you the effect. Effect in terms of which you can see. Generally, I would say. See, there are. We have seen. I told you that cause and effect which you can see. I'm asking this question. You can see means you can see the load because you see the object, you see the material is there in the object, so you can understand the load. You can see the load. We can say. And what will be the effect which you can see?
Stresses are developed.
No. See. Whenever I ask you which you can see, that means I'm asking you the physical behavior. Physical behavior is different than the mathematics. Yeah. So settlement or deformation. This will try to shorten in length. Yes or no? This is short hoga na. This will reduce. So you can see before the load. Now it is a dead load. So if you keep this object on the ground, then it will try to deflect. So its length will reduce. Okay. So before putting on the ground, it was, let's say, L, and after putting on the ground, it is L minus delta L. So it got reduced. So you can see this deflection. So this deflection is a effect. So what this force is causing? The deflection. Whenever I say you can see means it is a physical behavior which you can see. We are not talking anything related with this delta. See, you cannot see the delta. For understanding, I'm just telling you, but what you can see after the load, you can only see this line. That means deformation you can see. You don't know. Unless you measure this, you will not understand how much is the deformation. But you can see that it is deflecting down. Then there is, so why it is, we can say, compressive force, which is a gravity force. And as it is passing through this axis directly, it is a gravity compressive force. Now you have seen that effect. Now let's say there is a stone boulder. Okay, and I'm not much great in the sketching, but let's say try to this. Okay, so this person is trying to pull this. Okay, he's trying to pull this in this direction. So this boulder will try to move in this direction. So what will happen to this rope? What will happen to this rope?
Stretch.
Tension will.
Tension.
Yes, so
Tension, extend.
It will extend. Yes, so extend, what you said, extend or elongate. So these are the physical terms which you can see through your eyes, that the length got increased. So this is a physical understanding of this. And when you understand that the length gets elongated, so what kind of force is there in this rope? Force in this rope?
Tension.
It will be tension. That means when there is a elongation of that member, you can call that there is a tension within that member. So the tension is indirect term which you cannot feel or sense unless you can see this elongation. Okay, so whenever you see any elongation in the member, then and then there is a tension. So it is an indirect term, we can say. We cannot understand tension. We can only understand, or we can only see the elongation. Similar way here also, we cannot understand the compression or whatever force you are talking. We can see that previously the length was this and now the length got reduced. That means there is a compression. So compression, tension are indirect terms. Only you can understand through the change in shape, either elongation or compression. So what this force is causing or load is causing? It is causing deformation, either compression or elongation. Now let's see one more thing here. Let's go much in the now mathematical part now. If I ask you, let's say, this is object placed on the table and this is a plan of the object. Let's say this is a plan and this block is kept on the table. Let me draw the table also. I think, let's say this is a table. Now if I push this, push means I'm just pushing this by hand in this direction. What will happen to this object? This is freely kept on the table. This is a plan of the table. What will happen to this object? It will move, isn't it? So it was previously here and now it is here, right? Isn't it? Can you understand this?
Yes, sir.
Yeah. Then let's say if I am moving this way, so what will happen? It will move vertically, like this. So it depends whether whenever you are applying any force, apply at the center of that. Correct. If you are applying exactly at the center the force, then it will translate or move linearly in this direction. Correct. And it will deflect whatever may be the deflection. Now there is one more question. So now there are two people. One person is moving this object in this direction and one person is moving in this direction. So what will happen to this object? क्या होगा? One person is moving here, one person is moving in this direction. What will happen to this? What do you understand?
Table will move in the resultant of the two forces.
Yeah, so somewhere let's say like this, maybe
Yes, sir.
it will move like this, something. So it depends in which direction it will move. Now, if this person, let's say this person is pushing this by 10 kilonewton. I'm just giving the example. Yeah. For just simplicity, this is pushing by 10 kilonewton, this person, and this person is pushing this by 50 per kilonewton. So how will be the deflection or movement of this object? This horizontal force is less and this vertical is more. So it may happen that या ऐसे कुछ तो होगा. So imagine this. Right? समझ में आ रहा है?
Yes,
कि
sir.
this will have more vertical movement than the horizontal movement. And if it is a reverse case, either this is 10 kilonewton and this is 50, then it will be something different. Let's say I take this as a. See, I'm taking this example just to create a different kind of understanding in you. See, concepts learning through books may not give you this feeling. So I'm trying to give you certain different type of example actually. Here we are not learning the mathematics. Try to understand. You can refer the books and you can understand the maths. But you should understand the concepts along with the maths, the feeling and understanding behind that concept. So समझो ये 50 है. Let's say this is 50 and this is 10, then it will be something like this, right? And if the both forces are same, what will happen? Both are giving the same force. This is also pushing by the same force and that person is also pushing by the same force. This is also 50, this is also 50. What will happen to this? This will give some kind of uniformly. Diagonally it will go, right? Yes or no? So this will be in
Sir.
diagonal, right? Now I will just show this. So let me forget this now, numbers. I'm not taking the numbers here in this case. Let me remove this. Now let's say I call this as a force FH, as it is a horizontal force. Let me call this as a FV. And as I told you, this will move somewhere. I don't know how it is moving, but let's say, let me just give that. Some movement will be there. How much will be there? Now that means previously this was the center of that. So this was your center previously. Now this center got shifted somewhere here, right? That means it got moved in this direction. Correct? See, this is a center I am drawing. So previously the red center was here of this. And now this blue means after a moment the center got shifted here. So this arrow, whatever I have drawn, what this arrow is called as? क्या बोलते हैं इसको हम?
Resultant.
So this is called as the resultant. And if you want to understand the location of that object, then you can find the location by calculating this angle theta, right? Now if I show this equivalently, so let's say your equivalent, either you can show this by this two forces, or you can show like this. So I may write like this. So it may be something like this. So this will be my R. So if I push by this resultant force in this direction, okay, then again the same behavior will be there. You will see the same behavior. So either you give the forces horizontal and vertical, or you give the resultant force at this theta angle, you will get the same result. Okay. So generally, whenever there are different forces available in the objects, you can use the resultant of the forces for your calculations. So what will be the resultant of this? If you want to calculate the R value, kitna rahega R? So R will be something.
FH plus
Root of FV square plus FH square.
So FV square plus FH square. So it will be the resultant. And what will be the angle? If you want to calculate the angle, kya rahega angle? So I can put this in this fashion now. Now this is our FV. Horizontal is our FH, and there is some resultant at angle theta. You can see this. Okay. This is a resultant. So what is the angle? Theta.
Theta is equal to tan inverse of FV upon my FH.
So this way you can calculate the resultants, and we require this resolution of this. We call it as a resolution of forces, right? We have learned in the mechanics, I think, first year. I think so. And if you know the resultant, what will be this value in terms of resultant? FH is how much? In terms of resultant, R cos. You know this adjacent side. And
R cos theta.
FU will be R sin theta.
FV R sin theta.
Okay, now let's go in. We can say. So we know there were two forces here. So two forces are there. Now if we have more forces in the object, समझो ये है मेरा object. I have this object and now there are forces. So let's say there is one force like this. Let me call it as a F2. Let's say F1. This is F1. And let's say there is one force like this. So there are a number of forces actually here. See, all these forces are going through the center. Don't forget this. Okay. Now tell me, and let's say F3. So how to calculate the resultant of these forces?
Summation of all.
So it will not be direct summation. So I need to resolve this actually. So I will resolve in the horizontal and vertical direction. So it will be my H2, we can say. Let me call this as H2 for this. This will be my V2, right? Then let me call this as a H1. Then it will be H2. there is definitely one angle here, theta 2, let me call it as. Then let's say this is a theta 1, and this is not having any, because it is in this direction. So this F3 is nothing but my, as it is vertical, I can call it as a V3. This will be V2. Sorry. V1. This is V1 corresponding to F1. Just I'm using this 1, 1, 1. But as it is in the vertical direction purely, I can call it as a V3. And there is no horizontal force for this because it is purely vertical. Now, then I will calculate the total summation of the vertical forces, sigma V. So summation of vertical forces. What will be the summation of vertical forces? V1, let's say assume upward as a positive. Okay. And rightward is a positive. Okay. So how much is this? V1 is upward, so positive V1. V2 is downward, minus V2. And V3 is again upward, plus V3. Yes or no? So what will be the horizontal forces? Summation of horizontal force. H1. So say, let's say this is our assumption of positive forces. This is also plus, this is also plus. So H1 is plus, right? H2 again plus. And is there any H3? Is there H3?
No, sir. No, sir.
Because, yeah, purely. Now, once you know this summation, then you can definitely calculate the resultant by square of the H, this summation of all horizontal forces and summation of all vertical forces square. And again, what will be the theta? Tan inverse of sigma V upon sigma. Right? Are you getting this? Simple.
Yes, sir.
Finally, you can say the equivalent of this is nothing but there will be so finally whatever I am doing, I'm getting some R value here. Oh. So I'll get some R value. I don't know in which direction, somewhere like this, we can say. So this will be my R value and this will be my theta. Resultant finally. Okay. What this resultant of forces? So you have understood the tension. When there is elongation, there is a tension. When there is a shortening of that member, we can call it as a compression. So compression and tension, you got this. Now let's go to the next term after the tension and compression. So first we have seen compression, then we have seen tension, and now let's see one more term, that is moment. Whatever we are going to learn in our this basic concept sessions, that is the only thing which is there in the structural engineering, and it applies for all kind of structures. So it is really, these are sessions are really important. I know that you may be, some people are experienced and they may be knowing these term things, but still you try to learn this in a different fashion or different way. So it is always whenever you learn the things many times in different ways, your understanding gets developed. I am not starting this actually the complex terms in the beginning. Let's say we have this block and समझो ये ऐसे कुछ तो है ब्लॉक. So let's say this person is having weight that we understood. Let's say this weight of this person is P. Okay. So what will happen due to his weight? For the time being, just assume that this is anchored here. Huh? So, or I would say I'll do one thing. Yeah, ऐसे नहीं दिखा था मैंने तो confusion हो जाएगा. You may feel that it will topple, isn't it? अभी topple वगैरह छोड़ता हूँ मैं. Now tell me what will happen due to this weight.
There will be bending of the beam.
Yeah, so you will see that it will try to bend, and the bending will be something like this.
Yes, sir. Okay, so the bend, it will try to bend.
Deflected.
Yeah, so this is bending, and who is causing this bending? This force P, right? So I can say the previously the line was horizontal. So previously this top line was horizontal, and now it got say bent, but I am just drawing the tangent to this. So there will be the theta angle. So there is angular deflection, we can say, right? The deflection is angular. It is not linear like tension or compression. It is angular because this to the curvature I am just drawing this blue line, and this theta is the angle. So I can call that it is an angular deflection, or as we said, it is a bending, whatever you want to say. So that means why it is bending now. Can anybody tell me what is the reason of bending? क्या दिख रहा है आपका? क्यों bend हो रहा है? So what are the terms or what are the things which are causing this bending?
Load. The person is standing on the free end.
Yeah, it is standing on the free end, and it is standing away from this point, which is, I can call that point of rotation or something. So the load is out of plane load. So in the compression, what was the case? It was passing through the axis of the member in compression. And in your even tension also, if there is a rope and let's say I have a weight over here, it is also passing through the same line, right? Now, in our case, in this case, what is the load direction? It is out of plane. For example, let's say I have a pole like this, and I am putting the load like this. Is it the load passing through the axis of the member? No, it is out of plane of that member, right? So this will cause a bending like this. ये bend होगा ऐसे cantilever के साथ. So यहाँ भी ये हो रहा है. The load is out of plane to that member, and there is one more thing which is causing. It is away from the support. It is away from the support, and it is also out of plane. The load direction is perpendicular to the axis of this member. So my axis is like this and my load is like this, and this is my support. So there is a person P, the load P, and there is a distance also which is causing that. So this L, so I will call this L. So if I want to draw this in a mathematical format, this is the format of this. So support I will mention like this. Generally we call it as a fixed support. Then this horizontal line, and vertical load like this. So this is a physical object which I have drawn, and this is a mathematical representation of this. So there is a distance L and force P perpendicular to the member, and this is causing that bending or angular deflection. So what is moment then? What is a moment?
WL square by 2.
No. See,
P
there is
into
no-
L.
so there is just force into distance, isn't it?
P into L. Yes.
P
Sir.
into L. So I'm ignoring the weight of this bar, horizontal bar, for the time being. Just ignore this bar. So there is a P and there is a L. So what is the unit of this moment? P is in
Kilonewton meter.
P is a force.
Kilonewton meter.
So P is a force which we write in kilonewton, and this is meter. So kilonewton meter is the unit of the moment. So due to this load, now this is not moving from this point, isn't it? From this point, this bar is not moving. That means somebody is trying to hold it here. So as we have anchored here, this is a concrete block, solid block, let's say, and we have anchored this. That means there is somebody who is resisting this point not to move from here. And that resistance, we can call it as a reaction, right? Isn't it? Are you getting this? So there is a reaction developed by this concrete block. And what will be the value of this reaction? कितना रहेगा reaction? जितना
Equals
vertical
to
load है उतना
Moment.
reaction है. So R will be P. So there is one point that reaction is P in vertical direction. And as this is trying to rotate like this, so this is causing moment. How much is this moment?
P into L.
P into L. So it will try to resist also. So this is moving in the clockwise direction. The resistance will be on the anti-clockwise direction. So there will be the resisting moment also. The value will be same. Then and then it will resist. Getting? So this is a moment. Now for the block, let's say take first example of simple block, and then we'll see what is reaction and that. Let's say there is a block and block has a weight. So let's say this weight is P. So this ground will try to resist this force. So what that resistance we can call it as a reaction. So this P is nothing but action, and this R is nothing but reaction. Then and then two objects can be in equilibrium, isn't it? Otherwise this will move. If this settles down, what will happen? We cannot say that it is in equilibrium. So this is an action P and this is a reaction caused. And what is the value of R? कितना रहेगा value?
P.
P only. So let's say this P 10 kilonewton का हमारा force है action, then reaction will also be 10 kilonewton. And they should be in one line. So if this is action, then this reaction, so they are in one line. Don't forget this. Okay, they are in one line. So let's take again one example. So if this is an object, this is the center point of this, and if you apply this force, this will try to translate in vertical direction like this. Okay, तो ये ऐसे होगा कुछ तो. If this is the case, and if so मुझे यहाँ एक rod मैंने लगा है. I have put one rod over here, and now I am just putting a force here. Force. And what will happen to this object? क्या होगा इसका?
It will rotate.
So yes, so it will rotate. See, I'm just trying to show all these things using sketches. The reason behind is the understanding gets developed through sketches and through visual observation only. So you can see the real objects or real structures because we can see different structures surrounding us. You can see the bridge, you can see the building, you can see the retaining walls, you can see whatever structures are available on the ground. Through observation only, you can understand a lot of things. So see, we generally miss this. So we generally learn in the books. Well, I'm just going a little away from the topic for the time being. See, whatever we have learned in the colleges, schools till now, we have learned the books, and in books you might have seen the only images like this. समझो ये ऐसे कुछ तो है member, ये frame है. This is your frame, this is your frame, this is your load. Or there may be this is your support shown like this, support, fixed support, then there is a load. Okay, see, these diagrams are actually mathematical diagrams. So whatever we see in the books in this kind of line diagrams or line sketches, they are mathematical models, or I would say these are abstract images or abstract sketches. And whenever there is abstract, there is a problem in understanding. Are you getting what I am trying to say? So whenever there is abstract, you cannot understand the things. But if I tell you, please see the real building. Just go on the road and see the real building through your eyes. This is a real building, or we can say physical. How you can see that? Through your eyes. See through your eyes. And seeing through your eyes is called as observations. Okay. So many times, this is my understanding that there is a problem in understanding the subject regarding the structural engineering. I have seen that is only due to the abstract images, whatever we have seen in the books. So there is no real connection with the real structure and the book images. So we are losing the connection between these two. So this connection line is really missing, and that is only because we don't know how to observe the things. So please develop your observation skills whenever you work in the structural engineering. And that's why we are trying to, I know that I am also giving you the images which are abstract, but still I am trying to show you this person just to give you a feel of that person or weight. So many times all the things cannot be discussed in real way, I know, but try to understand. You have to see that in real way also. Mostly develop that skill, observation skill, and then you can come to this mathematical image, and then you can understand the concepts. So develop this way. We will share you some photographs also in the sessions of the real structures to just give a feel of it, and how can we analyze those, how can we develop thinking behind that. Now yes, you can say once you put this force, it will rotate. So the rotation will be, if I want to show it mathematically, then previously it was here and now it got turned here. So there is a angular rotation theta. Just observe this. We are not calculating anything now. So due to the force, what will happen? There will be reaction here. So this force will have a reaction here somewhere, isn't it? I can call it as a reaction. This reaction will be F only. So let me write down this reaction as F only. So this will be F, this will be F. This is a reaction, this is action. And there is a distance between the two. Let's say this is a distance D. So what will be this now? So to the equivalent, if I want to show this equivalently, then I can say this is the force is nothing but it is F here with F into D. What is that F into D? Moment. Are you getting this?
Yes, sir.
This I am showing the equivalence of it. So generally in mathematics and structural mechanics, we need to show these kind of things, because for simplicity, for calculations, we are learning this. So this is the physical understanding that if you, this is let's say lever arm and you are putting one force, it will rotate. So why it is rotating? Because of the moment which is caused by F into D. So moment is F. So what is there? So there is a downward force definitely which is acting through this CG, and there is a moment developed due to this lever arm D and F. So moment M is equal to FD. So there is a downward moment M. So moment means we can say this. I am talking moment means external. Please try to understand. This is not bending moment. It is external moment caused due to the forces, caused due to the external forces. Right? This is the moment which I am talking, which is externally, which you can see in general. The way you are seeing this, that person, the man is there, and that
Yes,
person
sir.
is creating. So you can see this is the external moment. It is not bending moment. Please keep in mind. Now that means I can say that moment is nothing but a couple of forces. Generally, we can call it as a couple of force. Couple means, let's say this is a point, center point, and there is some, let's say I am having one rod here, and there is a force here, which is at 90 degree, as I told you already, perpendicular to this line. And let's say this is your distance D. Then this is nothing but F into D, which is nothing but M, which is a couple force, couple. So this couple is causing the moment. So this is a external, this is action, our action or external load, and there will be a reaction also like this. The reaction will be F. I hope you are getting this. समझ में आ रहा है ना सब?
So,
Yes, sir.
Okay. Let's go more. See, we are slowly going in detail of the things. First simpler things and then move on to the. Our basic courses, sessions may be a little more also. We are taking alternate days. Sometimes we may need to take more also. Sometimes I think so. I don't know, because it's really vast subject. Now see, let's say I have this object with force F here like this. Then I have force like this, and let's say this distance is nothing but D. This is also D. And all forces are F. So I can equivalently show this as I'm just splitting that part. So this is my F. This is my F. Again, this is my F. This is my F. Okay. So if you see this F and this F is right direction. This one is to the right, and this is to the left. So what will be the resultant force of this? क्या रहेगा resultant? F minus F कितना आएगा?
0.
So it will be 0. As this force is rightward, this force is leftward, will this object move? Only due to the resultant of this. Will this move? Ideally not, right? Displacement, linear displacement is 0. It will not move linearly. We and generally whatever we are saying, this F is this and this, we generally call it as Fx is equal to 0. These are the equilibrium equations. So this is the meaning. Fx is 0 means this right force is same as left force is same as right force, but the directions are opposite. So resultant is 0. As the resultant is 0, the displacement is also 0 in this case. Now similarly vertically, if you consider this right side, so what is there? So one is downward and one is upward. Let me show this first for simplicity. Downward and then upward force. In this case also same resultant kitna aega? Vertical resultant.
0.
So R will be 0, displacement is 0. That means generally we call it as a sigma Fy is equal to 0. Is it the only thing here? No. So this force, they are opposite in direction, and there is a lever arm also. Don't forget this. There is a lever arm, and whenever there is a lever arm, there is a couple formed due to these forces. So this couple is forming. So this is right, and this is left. So what kind of couple will form here? ऐसे कुछ तो होगा ना?
Clockwise.
Yeah, clockwise. It will have a clockwise couple, and that clockwise generally couple is nothing but force into distance. That is a moment. This will be clockwise moment m, and in this case it will be
Anti-clockwise.
so anti-clockwise moment. Distance same, as distance is same. ये distance है ना हमारा. So what is the resultant moment? ये भी m is equal to fd है, ये भी m is equal to fd. So what is the resultant moment? So
Zero.
this is my horizontal resultant, this is my vertical resultant, and this is my resultant moment. Okay, let me go. So resultant moment कितना है? ये लेफ्ट साइड से भी m है, राइट साइड से भी m है. So that means
0.
m minus m is equal to
0.
0. So my resultant moment 0. That means this object will not rotate, right? Rotate होगा क्या?
No, sir.
Or I would say rotation is equal to 0. So here rotation 0, displacement be 0, vertical displacement 0, horizontal displacement 0. So that means this body we can call it as an equilibrium, isn't it? So that means we need to learn what is meant by equilibrium. So can anybody tell me what do you understand by equilibrium?
External force.
Forces are balanced.
Yeah, forces are balanced. Okay, it's good term. I liked your way of say giving the answer. See, generally, whenever we give answer or whenever we try to understand something, try to understand first in very simple language. The language which is not mathematical, the language which is not engineering language, a common person language, we can say. So if you really want to understand the structural engineering, first you become a very common person. So the person who is a layman, labor, or any common person like us, which are non-engineers, how they will look at that observation is also essential for us. See what happens many times through our engineering, We have learned a lot of subjects, 30, 40 subjects. We have learned mathematics, maths 1, 2, 3, then engineering mechanics, SOM, TOS, and DAMS, and so many subjects. Due to too much of technical things, due to too much of technical, due to too much of mathematical, due to too much of engineering, too much we have learnt, and we have lost the basic understanding. इतना हमने ये किया है, so our brain has become more technical. So our brain is more technical now, ingenious brain. And sometimes due to that, he forgets common sense. See, many times you will see that engineers are they are not giving the answer in a correct way, or they forget the common sense, and they get exposed in front of the meeting or in any interviews or in any projects, because they always see the things in this technical and mathematical fashion, and unless they find any solid reason from the mathematics, technical things, or logic, they don't believe much. But there may be certain things where your common sense is sufficient to take a decision or to do something in this. So I would say, whenever you learn this in this training program, you can use your really common sense first. Very common sense. Now our technical part, let's go again. Our technical things. Now if let's say you are applying a load to this, what will happen to this object? This will move downward, yes or no? So
Yes,
can I
sir.
say that it is in equilibrium? Equilibrium hai kya ye?
No, sir.
So it is not equilibrium. You can say unstable. It is very unstable. In simple language, it is unstable. In engineering language, not equilibrium. In equilibrium or not equilibrium. Okay. Now, if I show this object again now. Oh. Now you might have seen that I'm using this graphical paper. Yes, one more point. I'm using this graphical paper because it gives me the reference lines, horizontal and vertical lines, so that I can draw the sketches more appropriate way. So whenever you use, you do the manual calculation on the paper, I suggest use the graph papers like this, square rule pages. This is general practice internationally. If you are doing any work manually in any office, structural engineering office, they generally use the square rule pages because it helps you to draw sketches to the scale and appropriately. See, it is not necessary that everybody is a good artist or sketch. The people may not have a good sketching skills, but if you have these grid pages, then at least you can do the do the sketches appropriately to the scale. Now, let's say now it is resting on the ground and there is a load P, load W, let's say. Now, can you say that it is equilibrium? है क्या? Yes.
Yes, sir.
So it is equilibrium, and I can say this is equilibrium in vertical direction. So I can say vertical equilibrium. Because it is stable in vertical direction. And that who is making this equilibrium condition? Who is making this? Due to,
Reaction.
so there is a reaction
Very
actually,
good.
equal and opposite reaction, R. R is equal to W. So this is causing that equilibrium, and that's why this object will be stationary at the same level vertically. So this W is downward and the reaction is upward, equal and opposite. That means I can say net resultant कितना आएगा इसका? How much is the net resultant?
Zero.
Yes. So W, this downward W and minus W. W minus W is 0. So resultant is 0. So I can say that sigma Fy is 0. This is a resultant, right? So this is the vertical equilibrium condition, you can see. और कुछ एग्जांपल लेंगे वर्टिकल इक्विलिब्रियम का, समझो लेट्स से देयर इज पर्सन लिफ्टिंग अ वेट, ऐसे कुछ तो आदमी है. अभी ये मेरा स्केचिंग, आई डोंट नो. थोड़ा स्केचिंग ये हो सकता है मेरा, ठीक है. लेट्स से पर्सन इज लिफ्टिंग द वेट. And this weight is, let's say 100 kg. यहाँ है हमारा, यहाँ 100 kg है. So if this person wants to stand vertically like this only, how can the equilibrium reaction का कितना आएगा यहाँ for equilibrium?
200. 200.
200 kg. Just a moment, कुछ तो प्रॉब्लम है. Wait a moment. Hello. Hello.
Yes.
There seems some problem actually, technical problem. I think we will conclude today's session. Do you have any questions?
No, sir.
No, sir.
Okay. Are you getting what I'm telling regarding this?
Yes, sir.
Okay. So if you have any questions also regarding these basics, please ask me. Any questions? Mr. Shahaji Patil, are you asking any question? Hello?
No, sir, no.
Okay, fine. Okay, then we will close today's session. We'll meet day
Okay.
after tomorrow on the
Okay,
same
okay.
time. Okay.
Okay, sir.
Okay. Good
Okay.
night.
Thank
Thank you.
you. Good night.
Good night.
Thank you, sir. Good
Sure.
night.
Thank you.